NEC section 210.21b2 addresses the ratings of receptacles connected to branch circuits, specifically those not subject to the requirements of 210.23a. This includes receptacles on 20 amps branch circuits as described by 210.23c. It's important to understand that while 210.23a focuses on the maximum connected load that can be served by a branch circuit, 210.21b2 deals with the maximum rating of a receptacle that can be installed on that branch circuit. These are distinct concepts. For example, consider a 15 amps receptacle installed on a 20 amps branch circuit. According to NEC 210.21b2, this is permissible. However, the maximum connected load that can be served by that branch circuit is limited to 16 amps per NEC 210.23a if using the 80% rule. The reason this is allowed is that the receptacle isn't necessarily the only load connected to the branch circuit. Other loads, such as lighting fixtures or other outlets, can also be connected. Therefore, deleting 210.21b2 would create confusion and potentially unsafe installations. NEC 210.21b2 is not redundant with NEC 210.23a. Understanding the difference between these sections is crucial for safe and compliant electrical installations. 210.23a addresses the maximum load, while 210.21b2 dictates the maximum receptacle rating. Always consult the most recent edition of the National Electrical Code and local amendments for the most accurate and up-to-date information. Remember that the NEC is a minimum standard, and additional requirements may apply based on local regulations or specific project needs. When working with electrical systems, always prioritize safety. Ensure that you are qualified and competent to perform the work, and always energize circuits before making any connections or modifications. If you are unsure about any aspect of electrical work, consult a qualified electrician. Firstly, consider the overcurrent protection device for the branch circuit. Secondly, determine the allowable ampacity of the conductors based on their size and insulation type, referring to NEC Table 310.15b16. Thirdly, assess the load requirements of all devices and equipment to be connected to the branch circuit. Fourthly, ensure that the receptacle ratings are suitable for the intended loads. Fifthly, verify that the installation complies with all applicable NEC requirements and local regulations. By carefully considering these factors, you can ensure a safe and compliant electrical installation. The NEC provides specific guidelines for receptacle ratings on various branch circuits to ensure safety and prevent overloading. For example, on a 15 amps branch circuit, the receptacles must have a rating of at least 15 amps. On a 20 amps branch circuit, one or more 15 amps or 20 amps receptacles can be installed. This allows for flexibility in connecting different types of loads, while still maintaining safety. It is important to note that the total load connected to a branch circuit must not exceed the ampacity of the circuit conductors or the rating of the overcurrent protection device. This helps to prevent overheating and potential fire hazards. When selecting receptacles for a particular application, consider the types of loads that will be connected and the frequency of use. For example, in areas with heavy appliance use, such as kitchens or laundry rooms, heavy-duty receptacles may be necessary to withstand the demands of frequent plugging and unplugging. In areas with sensitive electronic equipment, such as offices or home theaters, surge-protected receptacles can help to protect against voltage spikes and power fluctuations. Always follow the manufacturer's instructions when installing and using receptacles. Ensure that the receptacles are properly grounded to prevent electrical shock hazards. Regularly inspect receptacles for signs of damage or wear, such as cracks, loose connections, or discoloration. Replace any damaged receptacles immediately to prevent potential safety hazards. Remember that electrical work can be dangerous, and it is always best to consult a qualified electrician if you are unsure about any aspect of the installation or maintenance of electrical systems. Adhering to the NEC and following safe work practices will help to ensure the safety of yourself and others. Understanding the nuances of NEC sections like 210.21 210.21b2 and 210.23a is crucial for electrical professionals. These sections are not contradictory, but rather address different aspects of branch circuit design. One governs receptacle ratings, while the other governs the maximum connected load. Incorrectly interpreting these sections can lead to code violations and potentially hazardous installations. For example, if someone mistakenly believes that 210.21b2 is redundant, they might install only 20 amps receptacles on a 20 amps branch circuit, even if there's a need for low-rated receptacles for specific appliances. This could create a situation where the available receptacles are not suitable for the intended loads, leading to the use of adapters or extension cords, which can increase the risk of overloading. Similarly, misunderstanding 210.23a could lead to overloading the branch circuit by connecting too many devices or appliances. This can cause the circuit breaker to trip frequently, which is not only inconvenient but also a sign of a potential safety hazard. In addition to understanding the code requirements, it's also important to consider the practical implications of receptacle selection. For example, in a commercial setting, it might be beneficial to install tamper-resistant receptacles to prevent accidental contact with live parts, especially in areas accessible to children. In healthcare facilities, hospital-grade receptacles are required to provide a more reliable connection and withstand the rigors of frequent use. Furthermore, consider the environmental conditions in which the receptacles will be installed. In damp or wet locations, weather-resistant receptacles are necessary to prevent corrosion and electrical shock hazards. In areas with explosive or flammable materials, explosion-proof receptacles are required to prevent ignition. The selection of receptacles should be based on a comprehensive assessment of the application, considering the load requirements, environmental conditions, and safety concerns. Always consult with a qualified electrical engineer or inspector to ensure that the installation meets all applicable code requirements and industry standards. Remember that electrical safety is paramount, and any deviations from the code should be carefully evaluated and justified. Staying up to date with the latest edition of the NEC and participating in continuing education courses can help electrical professionals maintain their knowledge and skills, ensuring safe and compliant installations. The distinction between 210.21b2 and 210.23a highlights the importance of understanding the different aspects of branch circuit design. While 210.23a focuses on the overall load on the circuit, 210.21b2 focuses on the individual connection points. You can think of it like a water pipe system, where the pipe size is like the branch circuit ampacity, which governs the overall flow, and the faucets, which are like the receptacles and which governs the individual connection point. You can have a large pipe that feeds several smaller faucets, but each faucet has its own flow rate. The NEC is designed to ensure that both the overall system and the individual connection points are safe and reliable. For example, consider a kitchen with a 20 amps branch circuit serving several receptacles. According to 210.21b2, you can install both 15 amps and 20 amps receptacles on this circuit. However, according to 210.23a, the total load connected to the circuit must not exceed 16 amps when considering 80% loading. This means that you can connect several small appliances to the 15 amps receptacles, but you cannot connect a large appliance that draws more than 16 amps to the 20 amps receptacle. If you were to connect a large appliance that draws more than 16 amps, the circuit breaker would trip, indicating an overload condition. The NEC is designed to prevent such overload conditions by limiting the maximum connected load on a branch circuit. In addition to the NEC, there may be other regulations or standards that apply to electrical installations. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for electrical equipment, including receptacles. These standards specify the physical dimensions, electrical ratings, and performance requirements for receptacles. Compliance with NEMA standards helps to ensure that receptacles are compatible with other electrical equipment and that they meet certain minimum performance levels. Furthermore, local building codes may have additional requirements for electrical installations. These requirements may vary depending on the location and the type of building. It's important to check with the local building department to determine the specific requirements that apply to your project. When designing an electrical system, it's also important to consider the future needs of the building. Will there be a need for additional receptacles or circuits in the future? Planning ahead can help to avoid costly and disruptive renovations later on. It's also a good idea to use high-quality materials and equipment that are designed to last. This can help to reduce maintenance costs and extend the life of the electrical system. Regular maintenance is also essential to ensure the safety and reliability of the electrical system. This includes inspecting receptacles, checking for loose connections, and testing ground fault circuit interrupters, or GFCIs. Any problems should be addressed promptly to prevent potential safety hazards. By following these guidelines, you can ensure that your electrical system is safe, reliable, and compliant with all applicable codes and standards. Remember that electrical work can be dangerous, and it's always best to consult a qualified electrician if you have any questions or concerns. The purpose of Section 210.21 is to allow the use of smaller amperage receptacles on circuits of higher amperage. This might seem counterintuitive at first, but it provides flexibility in designing circuits for various applications. For instance, consider a general-purpose office space. You might have a 20 amp circuit to provide ample power for multiple workstations. However, each individual workstation might only require a 15 amps receptacle for computers, monitors, and other small devices. Section 210.21 allows you to install 15 amps receptacles on that 20 amp circuit, as long as the overall load on the circuit doesn't exceed the 20 amps limit. This eliminates the need to run separate 15 amp circuits to each workstation, saving time and materials. However, it's crucial to remember the limitations imposed by 210.23 Even though you can install 15 amps receptacles on a 20 amp circuit, you still need to ensure that the total load connected to the circuit doesn't exceed 16 amps, again with 80% loading. This means carefully calculating the power consumption of all devices connected to the circuit and ensuring that the total is within the allowable limit. If the expected load exceeds 16 amps, you'll need to either reduce the number of devices connected to the circuit or run a separate circuit. Another important consideration is the type of devices that will be connected to the circuit. Some devices, such as appliances with heating elements or motors, can draw a significant amount of current when they first start up. This inrush current can briefly exceed the circuit's ampacity and cause the circuit breaker to trip. To avoid this, it's important to use receptacles and circuit breakers that are designed to handle inrush currents. Additionally, it's important to ensure that all receptacles are properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock hazards. The grounding system should be properly installed and maintained to ensure its effectiveness. Regular inspections can help to identify any problems with the grounding system, such as loose connections or corrosion. Any problems should be addressed promptly to prevent potential safety hazards. In addition to grounding, ground fault circuit interrupters, or GFCIs, provide additional protection against electrical shock hazards. GFCIs are designed to detect small imbalances in current flow and quickly shut off the power to the circuit. This can prevent serious injury or even death in the event of an electrical shock. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electrical shock. It's important to test GFCIs regularly to ensure that they are functioning properly. This can be done by pressing the test button on the GFCI and verifying that the power to the circuit is shut off. If the GFCI doesn't trip when the test button is pressed, it should be replaced immediately. By following these guidelines, you can ensure that your electrical system is safe and compliant with all applicable codes and standards. Remember that electrical work can be dangerous, and it's always best to consult a qualified electrician if you have any questions or concerns. The relationship between NEC 210.21 and 210.23 demonstrates how the code balances flexibility with safety. The code allows for different receptacle ratings in the same circuit to accommodate various load requirements, but it also sets limits on the total load to prevent overloading. This balance ensures that electrical systems are both functional and safe.